Welcome to this video lecture on the subject optical and microwave engineering. In this lecture, we are going to discuss about link power budget. So for optimizing a link power budget, an optical power loss model is to be studied as shown in this diagram, where LC denotes the losses occur at the connector and LSP denotes the losses occur at the splices and alpha denotes the losses occur in the fiber. So this system is the point-to-point link between optical fiber communication system. So there are transmitter, receivers and connectors which are used to connect the optical fiber to the transmitter and splices to connect the optical fibers. So we have to consider two connectors and splice component and optical fiber. So these are the losses associated with the devices in the optical fiber communication system. So each device loss should be considered when designing the link power budget for the optical communication system. So point to point link, so where all the losses from source to detector comprises the total power loss in the system. So link power margin considers the losses due to component aging and temperature fluctuations. Usually link margin of 6 to 8 dB is considered while estimating the link power budget. And formula for the total power loss is calculated from the connector loss plus splicing losses plus fiber attenuation plus system margin. So like this the total power loss is calculated, where L is the transmission distance. And we shall consider the example for calculating the link power budget. So design an optical fiber link for transmitting 15 megabits per second of a data for a distance of 4 kilometer with bit error rate of 10 power minus 19. So to design the optical fiber link, we have to calculate the losses associated with this system. So the bandwidth multiplied by the length is 15 megabits per second into 4 kilometer. So the total is 60 megabits per second. So the selecting optical source is the LED at 820 nanometer is suitable for short distances. And LED generates 10 dBm optical power. So selecting an optical detector is the pin FER optical detector is reliable and has the 50 dBm sensitivity. So selection of optical fibers. So the step index multimode fiber is selected. The fiber has the bandwidth length product of 100 megabits per second. So these are the data to be considered. And next is the link power budget calculation. So we have to assume the splicing losses as 0.5 dB per splice, connector losses is 1.5 dB and system link power margin is 8 dB. Fiber attenuation is 6 dB per kilometer. So the actual total loss is calculated using connector loss plus attenuation plus power margin. So 2 multiplied by the connector loss and then alpha which is the 6 and then L to be considered and then PM is the power margin. So these are the actual total loss. So and the answer is 35 decibels. Then maximum allowable system loss is to be considered. So it is Pmax equal to optical source output power, which is minus 10 dBm minus optical receiver sensitivity, so which is minus 50 dBm. So the answer is 40 dBm. So allowable loss is 40 dBm and power loss is 35 dB. So since the actual loss in the system are less than the allowable loss, the system is functional. So this is the link power budget calculation of an optical system. And next we shall consider another example where a transmitter has an output power of 0.1 milliwatt. It is used with the fiber having numerical aperture of 0.25 and attenuation of 6 dB per kilometer and length is 0.5 kilometer. So the link contains two connectors of 2 dB average loss. The receiver has a minimum acceptable power of minus 35 dBm So the designer has allowed a 4 dB margin. So calculate the link power budget. So for this we consider the source power as 0.1 milliwatt. So it is converted into dBm in minus 10 dBm. So the numerical aperture is given. So from this coupling loss is calculated. So the total loss calculated using actual output power is the source power minus the losses. So it is minus 33 dBm. So receiver sensitivity is minus 35 dBm. So the output power is greater than the P minimum. So the system will perform adequately over the system operating life. So in the next example, the output power in your fiber or link, the laser diode output power is 5 dBm. The source fiber coupling loss is 3 dB, connector loss of 2 dB and 50 splices of 0.1 dB loss. So fiber attenuation loss for 100 km is 25 dB. So compute the loss margin for APD receiver with sensitivity of minus 40 dBm, hybrid pin-fed high impedance receiver with sensitivity minus 32 dBm. So for this question we have to calculate the loss margin. So we can calculate using the available power to receiver is 5 dBm minus 35 dBm, which is minus 30 dBm. So for the APD receiver sensitivity of minus 40 dBm, the loss margin is when we subtracting we get 10 dBm, and for the pin fed we get 2 dBm. So this is how loss margin is calculated. Thank you for listening.